So hi everyone, I'm Charlie Clermont, Technical Director at Synaltic, and today I'm going to tell you how we transform a real-time flight simulation in a system into a modern analytical platform automatically managing 1,000 column with representing a 5 millisecond constraint. Spoiler alert, we use our secret weapon Apache Iceberg. Here in France, we started our company Synaltic since 2004, and with us 20 years helping customer to manage their data platform. We also organize meetups to promote open source technology since Hadoop. We also promote Spark, modern data stack, and now Apache Iceberg. Imagine a VHS cassette versus a digital video file. With the VHS, you can watch it, but it's impossible to ask, show me all the night scene. The digital file has metadata, duration, chapters, subtitle. In fact, our customer asked us to help him to have a queryable data from his simulation. It's something he could done with his platform. The existing architecture is a federated simulator with multiple systems communicating through a data bus, and all the system was written in C++. Flight data is recorded, but in a proprietary format. This format do not design for analytics, and this format do not allow our customer to have an eyes on this data. Business need were twofold. First, real-time analytics during simulation. Imagine an instructor seeing alert when the pilot make a mistake, and a second, cold analysis. Compare a pilot performance over the 6 months, identify pattern, feed for machine learning model. Our challenge was three main challenge. The first one was which cross-language serialization we will choose. In fact, we have an application built in C++, and we want to propage data to Kafka to the data lake, and to query that data after with technology like Dremio or Spark or Flink. So which serialization will we choose? The application written in C++ have a string serialization, a format near of the XML. Finally, we will see, but it's something we choose XML. The second challenge was to the flight simulator as a cycle of 20 milliseconds. So the simulator produces data every 20 milliseconds. So we have to serialize, push the data to Kafka in that delay. And the third challenge was all risk and all unknowns. What are the volume, the structure? What is the structure of the data? It is a hierarchic structure. It is a object structure. It was something we do not know at this time, and it's where we understand we will face something, an object with about 1,000 attributes. Okay, so finally, our first main challenge was to create what a data producer in C++ inside of the simulator. We have to embrace how the architecture, the software architecture, the software design of the simulator to put inside inside a Kafka producer in C++. For that, we choose the Morgan Stanley libraries for Kafka. And after, we also choose Red Panda because of it allows us to have a very nice performance because we need it. We have the constraint of the 20 milliseconds. So finally, we push the data in XML to a topic of Kafka. We have Flink to manage the real-time processing. We have two processors in Flink, one to store the XML file on storage on MinIO, and another one to translate the data in the XML data in JSON. Why we choose JSON? Because we anticipate we will want to store the data in Iceberg format through the Kafka Connect, the Iceberg Sink Kafka Connect. And after, with Dremio, we could finally manage the query. Some challenge we face is that we have to respect the constraint of the 20 milliseconds. We succeed, but it's well not so easy. We choose data compression to avoid too many network heavy. I don't know. Sorry for my word in English. And we also use hack to one because we want to have this ability to respect our constraint to the 20 milliseconds. So we do not opt to have all the data in each broker. The result was to have a data in 5 milliseconds. So we were very, very happy with the search result. Okay, because we have the data in XML, our first approach was to create the table manually, but it was not a very good idea because we have so many data and the schema of the data was changing. In fact, we have different kind of entity we propage from the C++ application to Kafka and finally Iceberg. So about 150 entities. So the same for the topic in Kafka. So manage all that table before we know which data we will have and which structure of the data we will have. It was a mess. So finally, we keep we keep iceberg. We keep the Kafka Connect Iceberg manage the schema evolution, and it was it was very helpful because because we have so many different message, so many different structure for the same entity. The this component, the Kafka Iceberg Sink, was very helpful. All of our data arrive in Iceberg, and the main observation we have at this time is that we have table with more than 1,000 columns, and without intervention, we could have all of our data in Iceberg. It was very magical. And finally, with all the data in Iceberg through Latency, we could in fact query the data. Here we have a concrete example with a CSR aircraft, a table about 100 columns at root level. This object direct attribute, but the object contain nested structure. Spatial contain position, which contain latitude and longitude, altitude. Spatial also contain velocity with x, y, and z for several levels. In total, over 1,000 columns in a nested structure. Apache Iceberg Parquet format handle these nested columns natively. This is these were flattened for querying. In Dremio, we were access to this deep field with standard do not notation. The spatial position latitude is transparent for SQL user. So in fact, for SQL user using Dremio, it was very easy to access that data. Dremio manage JSON format very well. So our user using Dremio were very happy with such proposition. In fact, we know why this flexibility was possible because of the separated metadata of Apache Iceberg and the capacity to add new column and only update metadata, and also what it with a Parquet format and the nested structure of Parquet, and something we also have in Apache Iceberg. We could in fact have these 1,000 columns in Iceberg, in our Iceberg table for the data of the flight simulator. One thing we will want to have at this moment, it was the variant type we have now in the v3 specification of Apache Iceberg. It will be very interesting for us to have that, and so we could have a natively queryable JSON data. Okay. Another thing, you know, we are in with this flight simulator in a real-time process. So we face as many person the small file problem. So with a commit every 60 seconds, 1 hour of simulation generate a 600 small file per okay. A negative impact on with performance. And the solution was to automatically compaction with Dremio. We could launch query of optimized table, and we also plan schedule this kind of query or some with this kind of operation. And we also use the vacuum table that clean up all the snapshot beyond 7 days, for example. Okay. For our customers, what he gain with a such project. The result for a technical side, the ingestion latency around 5 milliseconds, well, below target. We do not expect to have such a low latency. Also, we have an automatic management of the thousand of column, so it helps the customer to have to store data and manage later cold analytic, historical analytic. So we can compare a pilot evolution over 6 months, identifying scenario where the pilot generate most errors, and also optimize training program. For the in the real time aspect, because it was one of the needs of our customer. So instructor now have live dashboard with alerts. So when a pilot make a mistake, an automatic alert indicates the instructor that he have to indicate the pilot that he do not respect the trajectory or thing like that. We also imagine that many of industrial users already have legacy application written in C++. So what we understand is that the value proposition of our solution with create or manage a Kafka producer inside the application, take the data, put it in Kafka, create some process of live processing with Apache Flink, have two direction. One to manage the live processing, and also one to store the data in a cold analysis. This is process, this whole solution for us is a pattern, something industrial C++ user need to transform their analogical solution in a numerical one. So finally, what we could what we learn, and what you could learn too with our talk, is that many person could need this kind of solution. Many C++ application will need this kind architecture to have an analytical view of their activity. Also, we can manage Kafka with a fast buffer, and we could keep analytical archive in Iceberg format, and Iceberg also allow us to manage so many columns, also with a nested format. And for the future, we hope the variant type will simplify a lot our project. And finally, we also appreciate a lot the Kafka Connect Iceberg Sink from Tabular, and now in the Apache Kafka project, because it was very magical, as I said, to auto-create and involve a schema. So my talk is now finished.